Yeah, maybe we should like start. Is everyone ready to kind of just start? Because when we should just start then. Okay. So here we are, another Defen. This is like Defen, Nathan Marz, take 2.
Take 2. The best take.
Best take. Okay. Podcast, cameras, action. Nathan. Welcome to Defen.
They say third time's a charm. I've never heard of second time's a charm.
Well, we are on recording 7, let's not forget. So, we can
Lucky
son
7
of a 7th recording. I don't know. Yeah.
I actually have a theory about what happened with the last recording.
Okay.
Well, because
they didn't use Rama.
No. I think if we're honest about the last recording, it was a bloodbath. You guys absolutely totally. It was brutal. I was, man, my head was spinning afterwards. I started drinking again. It was bad. But my theory is I don't think you lost the recording at all. I think you guys had so much fun tearing me apart that you just wanted to do it again.
Oh, yeah. Yeah.
That could be true, yeah. I must admit that I'm not on heroin today, so it could be better, yeah.
Or worse, probably.
Or worse, yeah. Maybe it's worse, yeah. We'll have to decide. I think the nice thing about it, though, is that because we've teed it all up and we know that this is take 2, it'll be very interesting for the listeners to try and work out where take 2 ends and where take 1 begins. You've got to listen right to the end.
Exactly. All of them.
There wasn't no take 2. Yeah, I don't know. Yeah, it's going to be fun. Yeah.
Yes. But Nathan, thanks so much for joining us again from scenic Honolulu. It is, right?
Yep, Honolulu.
Yeah, amazing that you would travel so far over the tubes to be on Zencastr with us.
Well, he's on Defen with us, actually. Zencastr is just a bullshit thing that ruined our first take, remember?
Exactly. Ruined my life, actually. No, Nathan's life, because he started drinking. All right, my life is fine. Yeah. So...
it's really making us nervous now. This is so much worse. We really ripped into him the first time. It was so much better. Jesus Christ, Nathan, you've totally you've totally outpsyched us.
Yeah, I set some expectations for the audience. They're expecting quite a performance from you guys this time.
I think the thing that started the bloodbath was the kind of legendary VJ question, Nathan. So I'll put it to you again: Emacs or some other shit?
Yeah, I actually use. I have the most primitive setup possible. I just use Atom, which isn't even supported anymore. It's ceased development, and but it works fine for me. I just don't find that. Obviously, all the stuff in Emacs is nice. A lot of my employees use Emacs. It's pretty fancy, all the stuff you can do with it. But I just find programming is mostly just sitting there and thinking. So having the editor be better hasn't really made that much of a difference for me when I've experimented with it. So
that's interesting, because there was that Steve Yegi blog, where he spent 16,000 words telling you that you need to learn how to type faster, you lazy programmer. And that always I had the kind of same reaction as you just enunciated there, which is but typing is not the slow part of programming for me. It's my stupid brain trying to figure out, how to solve the problem, not my fingers typing the characters. But Yegi was doing Java at that point, so maybe that explains it.
Oh, I couldn't even imagine doing Java without IDE support for it, but Clojure is different for sure.
Yeah. Also, I think there's a difference in terms of expressivity. It's interesting. We one of the things we're going to talk about is productivity and efficiency and stuff like that. So, let's just think about it a little bit. So, if we're all thinking about stuff, and thinking is the big thing. I think there was a talk by Rich Hickey about that, about how to get better at thinking, essentially, which was, because that's the real problem. So what do we do? If Emacs isn't going to help us, and typing, 70 words a minute isn't going to help us, then And yeah, what do you have any thoughts about that actually, Nathan, about like where thinking is going to help us? How do we get better at thinking?
Well, I do think a programming language is like a reification of a philosophy of how to think about of how to think about programming. And
Right.
Clojure and Lisps in general, they, I would say, offer a much more uh, powerful way to think about programming. I would say the same thing about Rama too. It offers a much more powerful way to think about
Hmm.
backend development and data processing, data indexing, and data ingestion. So one way to get better at thinking is to use better tools, I guess, or use tools that embrace a better way of thinking that allows you to think in a more
Yeah.
powerful way. If you're sticking with, um, you know, JavaScript and Python, kind of these like traditional languages, so to speak, then you are going to be fundamentally limited into thinking in the ways that those languages have allow and encourage you to think. So I think that would be step one, and I think that
You
that's
are
always been.
undermining. Sorry, go ahead, Nathan. Then I'll
Uh,
tell you why you're wrong. But go.
I think that's something I've always personally been drawn to. Is just like I've always been interested like ever since I was like a child when I started
Hmm.
programming, and just like it was just so interesting to me that you could write programs that could help you write programs faster in the future, right? And so I was always interested in like languages and abstractions and stuff like that. And so I've always been searching for that. I've always been drawn. I mean, that's ultimately what drew me to Lisp in the first place.
Well, actually, I would completely agree with Nathan about like Lisp because I mean we definitely talked about this first time around as well, which is that I grew up like most programmers, of course, thinking about stuff like with C or Java or C++, imperative languages, class object oriented languages, where obviously with C, mutability and changing things and allocating memory and all this kind of stuff and being careful about that is something which you have to be precise about. And that inevitably, all those bookkeeping activities just take up a lot of mental space, essentially. So then you get a garbage collector language like Java, and it turns out like Lisp. 1950 fucking nine. Anyway, the but the garbage collection frees you from a lot. I remember when I first had experienced Java, not having to think about alloc and free, and it was freeing. Haha. Okay, but but again, then the way that object orientation works is that you have to think about mutability differently. You have to think about essentially having an interface for mutability. You say, okay, do this thing on this object, and that changes the state of the object. Um, so you're moving mutability into every single object that you design, and managing state in every single object, which means again you're thinking about state all the time. You think about mutability all the time, and then when you go to closure and you realize, oh, actually, with functional programming in general, which says actually immutability is a huge problem, so get rid of it. It does actually, I think to Nathan's point, it does all those kind of things that you just drop off. Whilst they may cost you something in terms of raw power on a bit of metal, actually from a thinking perspective are incredibly enabling.
Yeah, it's kind of just embrace that humans are can only fit so much in their head at one time. Like
Hmm.
embrace your inherent stupidity, and then seriously, like you are like once you have too much stuff to think about at once, you're going to fail to be able to think about it properly. So if you can reduce the amount you need to think about, you'll be able to do more stuff. I don't think that's everything. I don't think that describes programming in general, but I think that is a big part of it, and certainly that's a big reason why immutability is so powerful. It
Yeah, yeah.
greatly reduces the amount you have to think about it. I was actually looking at a book that Dijkstra wrote in 1976. Fascinating to read. He obviously he's a very important person in the history of programming, but just absolutely fascinating to read how someone's writing about programming in 1976, when
Hmm.
even the concept of structured programming was like still pretty new and kind of controversial. Like not everyone
Yeah.
agreed with it. And just read. I was specifically reading the part about him writing about global variables, and he was
Mm.
talking about why they're harmful. And you could kind of take that argument and copy and paste it for why mutability is harmful, because he's writing
Mm.
about how global variables, in order to understand code locally, you have to understand all the code, because
Mm.
anything can be touching them, which is the exact
Yeah.
same reason why mutability is harmful. So I thought that
Mm.
was interesting to read.
Yeah, it's incredible. Yeah. And I think because he was a lot of people still talk about his algorithms, don't they? About like the A star algorithm and things like this for like
Yeah,
finding the shortest distance and all that kind of stuff.
I
But
think that
but
most
sorry.
people would know him from his algorithms,
Hmm.
but he wrote a lot about just like programming, like
Yeah.
as a
I mean, the famous go-to considered harmful, right? That was
yeah,
also Dijkstra.
Yes,
I
yes.
believe so. Yeah,
Similar to what you were just talking about. Yeah.
yeah, yeah.
Let's get back to your closure story because
Yeah.
this was something that definitely was like super interesting to both of us when we heard it the first time around.
I would say it started for me in, I think it was 2004. So when I was in college, and Paul Graham, he wrote an essay called "Beating the Averages," just talking about how he used Lisp at his startup and how it was instrumental to the startup success.
Hmm.
And there was one line in particular that really stood out to me, where it was I'm paraphrasing, but it was something to the effect of, our company was doing things that no other company could do, and Lisp, you could do stuff in Lisp in programming that you couldn't do in any other language, and these two things are connected. So I
Right.
found that really interesting, especially as I mentioned, like I was fascinated with programming languages and improving how you think and abstraction and stuff like that. And so I got really interested in Lisp at that point, and that was just common Lisp back then. This is years before Clojure came out. And actually, it was to the point I was interested that I knew that John McCarthy lived near campus. He was a retired professor at that point. So I found he just had his email on the website. So I emailed him and was like, I'm a sophomore, and I'd love to just meet you and learn about your life and career. And he emailed me back. He was like, sure, come by next Tuesday at 10 a.m.
That's-
I didn't really, I really didn't appreciate the significance of that back then. I was
yeah.
too young for that.
Yeah,
Yeah.
yeah, yeah, yeah.
Like obviously, I knew that he had created Lisp and was obviously big in AI. I didn't know much more beyond that. Like, I didn't like understand just like how, like the breadth of how foundational he was as a person to our entire field, like the entire
Hmm.
craft.
Yeah,
But
yeah.
I biked over there. It was like a 10-minute bike ride away. Um, knocked on the door. He invited me in, and we sat, and I actually sat with him for 2 hours and was asking him. Just he took me through all his time at MIT and Stanford, and I wish I had a recording of the conversation because I don't remember. It's been more than 20 years at this point. But
Hmm. Hmm.
there are a couple things I remember very vividly. One was that he was really confused that I kept asking him about Lisp. Because like, and it occurred to me afterwards that he really didn't care very much about Lisp. Like what he cared about was AI, and Lisp was
Right.
just something that he created to help him with AI, his real passion. Um,
Yeah, yeah.
and like it's so crazy, like when you look back at like what he just like generated in, I think it was 1957, 1958, something like that, when he first proposed Lisp. I think it was.
Yeah.
I don't think it was implemented until 1960. But like,
Yeah. I think the
yeah,
paper was 59, maybe. I have that stuck in my mind, but yeah.
maybe maybe that's when it was published. But yeah, I mean, symbolic manipulation and like GC as like a concept.
Yeah, yeah, yeah.
Again, we already mentioned like Dijkstra was writing about structured programming was controversial in the 70s still.
Right.
Yeah, yeah, yeah. Yes.
1959, like he's already talking
Yeah.
about Lisp and all the advanced stuff. Like it's pretty it's like unbelievable what he accomplished
Yeah.
there. But anyway, he didn't care, or he apparently didn't care. And it actually it reminds me a lot of Isaac Newton, actually, because um, obviously invented calculus, very, very important milestone in mathematics, but he only
Right.
did that for physics. That's what he actually cared about, right?
Exactly.
Yeah,
Um,
yeah, yeah, yeah.
for me, there's like a big parallel between Isaac Newton and John McCarthy there.
Although if I'm not wrong, Isaac Newton did really give a fuck about calculus because he fought Leibniz over its he wanted credit for creating it. There was a war between him and Leibniz where there wasn't such a let's say controversy around Lisp. No one else was claiming to have invented it or discover it, I think.
So the Leibniz Newton beef had more to do with religion than it did with mathematics, though, because Leibniz had this concept of the ether and monads. That was the thing he had. Not the mathematical sort of monad, but
Okay.
this monad that was some kind of like instantiation of God. And Newton was like, that sounds like some anti Christian bullshit to me, bro. And Leibniz was like, come at me, bro. And then it went on like that.
Yeah,
Probably in French at the time, they would have been speaking French. So,
yeah.
um, but anyway, yes. Yeah.
No, let's
Latin, probably.
no, let's, no. I think theology is a great direction for this podcast. I think we should continue.
Totally. I mean, so you definitely you saw the light and came to closure eventually.
Yeah.
But how did the rest? So I'll give a brief interlude to talk about myself because I love myself more than even the calculus. So you mentioned Paul Graham, and I had the exact same journey, like the first step into closure as you did. I read Hackers and Painters, which is book of essays that had that beating the averages in it
Mm.
and a bunch of other stuff. And I had taken like a common Lisp in a programming languages course in university and been shocked and appalled by how awful it was. And I was convinced that Lisp was like pointless. And then I read this book of essays by this guy who was making sense. And I was like, oh, well, maybe I was not as right as I thought I was. So I better look back into this. And when I looked, what I found was Scheme instead of Common Lisp, and the simplicity of Scheme just spoke to me, and that really got me started on the whole journey. But um, just before I go any farther, I do want to assure listeners that I think Paul Graham is an awful human being, but that doesn't make him wrong about everything. So, anyway, Nathan, how did you move on from your interest in Common Lisp to Clojure?
So yeah, so after I graduated, um, I was working on I started my career like working on big data stuff. So right when like Hadoop was starting to gain a lot of
Mm.
popularity, and just doing a lot of like batch processing stuff. And then I had this idea. I had learned data log in college from some college course. And then I had this idea to do data log on MapReduce. So compile data log into, chains of MapReduce jobs. And I actually built like a data log to MapReduce compiler. And my first version was like literally just like data log as its own language with a lexer and parser. And just immediately ran into issues with that. Like it was immediately evident that like you need to put in like custom logic in there, like custom functions as part of your data log workflows. And I had to build like a manual registration system for it. It was like very, very messy. But I had heard about Clojure probably from Hacker News or something, just like in the ether. And then it just like connected in my mind, like, oh, like it seems like Clojure would be really good for this. It's already on the JVM. You could use macros to form these data log abstractions, which are obviously they execute differently than like a standard language, but you could smooth all that away through macros. And so that's when I started with Clojure. And my first or my goal or my motivation was what eventually became task log, right? So a data log
Mm.
like thing
Mm.
on top of MapReduce. The first project I did was I did another project first just to get like the hang of Clojure. It was some sort of like queuing system or something that I built. But my second project was Cascalog, which was a very, very ambitious project for
Yeah.
Exactly.
and
Yeah, I wrote the Linux kernel as my first C project, you know.
yeah,
Second,
right,
Second,
second.
sorry, yeah.
yeah, yeah.
The first you do like Hello World, and then you do the Linux kernel.
Yeah,
That's basically what it was like for me. And so yeah, my
yeah,
first I didn't really know how to program Clojure well at that point, right? So certainly looking back, um, I would have the implementation of Catalog could have been a lot better, but the API was beautiful. It was a really beautiful API.
mm-hmm.
And then I learned things from that, right? By doing data log within Clojure, so doing it within the context of a full programming language, like you're not sacrificing the power of a programming language in the process of creating this other one, right? And then I learned very, very quickly, like that's really useful because it was really useful to write Clojure code, which would dynamically create Cascalog code. And it was completely trivial to do because I never sacrificed that in the first place, which is something that programmers are all too quick to do, which is to just sacrifice programmability for no reason. With, like as soon as you do like a true DSL, which is actually like its own language, you have made a massive sacrifice, which you may never fully appreciate because you never got to experience it if you hadn't sacrificed that, right?
Mm-hmm.
Yeah. And like obviously like SQL would be the prime example of that. And it's like, it's fun, if you want to use SQL from a regular language, like it fundamentally comes down to just string manipulation, right?
Yeah.
Anyway, that was a big, I think, lesson for me from building Cascalog, which I definitely internalized and carried forward as just like as part of my philosophy for programming.
I think the other thing to me about SQL it's kind of interesting and it's instructive at least is that on the one hand it feels like it's fairly universal, but on the other hand we all know that it isn't. That every single version of SQL beyond like select star from emp is completely different. They all have completely different affordances. They all have completely, they have different extensions now, but even the core things don't seem to work very well together. And it's become more than just this declarative languages. It's all to do with the way that you create schemas and manage schemas. And so the whole operationalization of SQL has become a huge problem. Because it's one of these things which starts off, again, it's like hello world. It seems very simple to just make a SQL statement and to use SQL as forgetting all the string manipulation. Just SQL itself just seems like, okay, I'll just walk up to this thing and do some querying, and relational technology in general seems really good. But yeah, SQL as a sort of gateway into relational technology seems off, I would say. And I'm wondering what you think about like Datalog then, because Datalog is also like, it's very varied now. There's there's RDF and stuff like that that have their own flavor of Datalog. And in like the Clojure world, we have Datomic and Juxt, and there's a whole bunch of other Datalogs as well, actually. I can't remember the other one. Data 11, I think, Data 11. There's a few other bits and pieces, that have. So that's not a standard either. Maybe it's just not important to have standards. I don't know.
Yeah.
Just Chuck. We all know the XKCD cartoon about standards, right? All of the 11 existing standards suck, so I'm gonna produce a 12th to fix it.
Right.
Mm-hmm.
Well, I have a lot of problems with SQL. I have a lot of problems with and we'll talk about, we'll get into Rama, right? But just the whole concept of a fixed data model is really problematic. And obviously relational database is the, I guess, most popular fixed data model that people use and have become lines for, basically since the 1980s, right? But I think it's a fundamental problem to just even think about data indexing in terms of fixed data models. And that's one of the big things that Rama addresses. And I think a lot of the problems with relational databases and through the usage of SQL stems from the fact that it is a fixed data model.
Yeah, I think it's kind of what we were talking about, or what the kind of SQL people were talking about was sort of almost like the opposite of that, wasn't it? It was like that IBM back in the 60s, 70s, 80s, well, 60s and 70s, let's say, they had they had files, and these programs were difficult to get into. Like the file formats were all different, so it made it very difficult to write reusable programs when all of the files were different. So SQL was a sort of way to, let's say, normalize data representation. I mean, it started with ISAM and stuff like that, other VSAM and all these other sort of structures. But in the end, relational technology kind of won in terms of like the lingua franca for sharing data across different projects. So I think in that sense, it was sort of a success, in the
Oh yeah.
sense that it allowed you to write more reusable programs.
Well, but in
But
19, in
go on,
1980,
sorry.
yeah, in
Yeah,
1980,
yeah,
the computing landscape was completely different than it is today. You had
absolutely.
severe restrictions on CPU and memory and disk being available, and I think you have to like analyze it in detail, but it's possible that a relational database was the best thing that could possibly be done at that time, given the resources. But it's also insane to think that that would be the best technology to use now when the computing landscape is not comparable at all.
Yeah.
So like basically what I'm saying is that it's possible that the best we could do was one fixed data model and everything built on top of that, and have that be extremely highly optimized for a low resource environment. But that is definitely not the case today.
Yeah, I just before I want to quote. I just want to pull out this Mark Fisher quote, which is like the people find it easier to imagine the end of the world than the end of capitalism, and I feel like people feel like it's easier to manage the end of computing than it is to manage or to think about the end of the relational database. It feels a bit like that, kind of like, oh my god, we're hooked on it now. We really are. The whole world is hooked on this stuff.
Yeah,
So that's how I mean, regardless of right or wrong, it does feel like that's the kind of vibe that we're getting off the world of
that's yeah. I mean, that's actually one of the interesting challenges that I'm facing, like directly. It's just like
yeah, yeah, yeah,
amount,
yeah, yeah,
amount by which people have internalized that way of thinking, like that
yeah.
relational database centric way of thinking, and then just more generally like fixed data models, and they can't get their heads out of it. And I've created a tool which completely rejects that. It's a massive rethinking of programming. And so a lot of my challenge isn't so much getting people to learn Rama, but getting them to unlearn everything else.
Right.
Mm, mm.
Yeah, so it's like Rama is. I would say actually, the unlearning curve to Rama might be bigger than the learning curve,
Yeah, yeah, yeah,
Yeah.
yeah, yeah.
yeah,
Yeah.
which is a kind of interesting challenge.
Yeah.
Um,
That's some Zen type shit you're spitting there, Nathan.
but I do think in a lot of ways, someone who's well, okay, I won't say someone who's never programmed before, but someone who's more naive in programming might have an easier time learning Rama because they're not hung up with all these preconceived notions
Yeah.
in the first
Mm,
place.
mm.
I've thought the same about Lisp itself, right? Like
Yeah,
if you don't learn an Algo 60 style language first, but you just learn Lisp, which, is more mathematical, right? It's more like the arithmetic you learn in school. Wouldn't it be easier? So I did try that with my son. Unfortunately, he never really got the programming bugs, so I can't claim that that Lisp was easier. But you've mentioned Rama a few times, and I like that that snarky comment you made about, well, maybe that was the best we could do in 1980, but it's not the best we can do today. So what is the best we can do today, Nathan?
Yeah. So, all right. Well, let me explain what Rama is. So Rama, let me start with just framing Rama in terms of existing concept and technologies that people already know. But let me just say up front that this is also not a good way to think of Rama because it limits you into thinking in terms of the limitations of those toolings, right? But you can kind of think of
Right.
Rama as like a stream processing platform with a database built in. Or maybe it's more accurate as a streaming platform with every database built in, or every possible database built in. And so Rama, so whereas like um, a traditional architecture for building like a backend, small or large, it doesn't matter.
Mm-hmm.
Like the model of thinking would be you have your application layer and you have your database layer. Your database layer is the current state of the world, and your application layer does reads and writes to your database layer, right?
Mm-hmm.
So Rama's model is fundamentally different. So Rama is based on event sourcing and materialized views. And the idea is that you keep your data separate from the views which you use to support the queries of your application. Data is append only. So you're just always appending new data. And then you construct your views, and you construct as many views as you need, for however you need to be able to slice and dice through that data quickly. So that's the general model of Rama. And so you have, like I already mentioned, fixed data models a few times, right? Fixed data models would be like relational database, key value, document, graph, column oriented, and there's some more. So Rama, uh, Rama, the views that you create in Rama are called P states, which means partition state. And every P state that you create, and you create as many as you need for your application, can be whatever data model you want, because P states are expressed in terms of data structures, not data models. So data structures like maps, sets, and lists, and so on. And any particular data model is just a particular combination of data structures, right? Key values, it's a map, documents, a map of maps, column oriented is a map of sorted maps, and so on. But then obviously with this simpler primitive of data structures, you can express all the existing data modules plus infinite more, because you can fine tune the structure of your views to precisely what you need for your application. And so you get, I would actually say, a uh, profound amount of flexibility, to, like, whereas before you kind of always had impedance mismatches with your database, because ultimately this data model is not going to fit perfectly for all your use cases. With
Mm-hmm.
Rama, those impedance mismatches are gone because you're always able to mold your indexes to precisely what you need for your application. I think that's analogous to just like Lisp, right? Where with like Lisp, you're able to mold the language to fit your application instead of having to force everything into just the constructs of the language. That I would say is the key thing that makes Lisp so powerful. And I would say the same thing applies to Rama in terms of the way you're able to mold Rama to fit your application rather than having to twist your application to fit your tooling. So at a very high level, that's what Rama is, and that's where its power comes from.
So in terms of let's say you have, we were talking about like why relational databases occurred is that they wanted to share the same data for different applications. And that's it's clear to me that in your explanation that should be possible with Rama as well. That you should be able to write 3 or 4 different applications or n applications with the same backend data as so you should your application, which is doing, let's say the classical kind of microservices pipeline where you've got customer shopping cart, and you've got the catalog, and you've got the sales process and the follow-up. All of those things should be able to operate in Rama
Yeah.
without kind of like fretting over the data structures at the back.
Yeah. So with Rama, like the mental model, you have your data coming in that comes into something called a depot. A depot in Rama, it's think of it like Kafka, right? It's a distributed queue, right? And then you have your P states, of which you have as many as you need, right? Some applications will have maybe just one P state, and other applications will need 100 P states. And then you write these things called topologies, which consume depot incoming like depot data as it arrives, and then materializes your P states, right? And the topology code is just code, right? It's we have a Java API for Rama and a Clojure API, and you just write your topology as just in Java or Clojure, right? With whatever logic you need. And then Rama as a platform is inherently distributed and scalable. And so the way the topologies are programmed are inherently distributed and scalable. It uses you program it with something called data flow. Rama is not the first system, but not by a long shot, to use data flow as a concept. But I would say Rama takes data flow and expands upon it, I would say, to the maximum extent possible. So Rama's data flow is exceptionally powerful to be able to do distributed computations in a very expressive way. And so like anything that you could imagine doing in the back end will fit into that model, right? Because it's completely arbitrary. Basically, the way you can represent your data in depots, completely arbitrary. You can use like you literally just use any type you want, right? Maybe you just use plain maps, maybe use JSON, maybe use Clojure records, or maybe use something, maybe use Thrift or Proto. It doesn't matter. It's completely up to you. Your P states are completely arbitrary. They can be any shape you want. You can have any number of them you want. And the topology code is also completely arbitrary. You have absolutely no restrictions on what you can compute, how you compute it, how you partition your computations and data, and so on. And so Rama is like an extremely general platform.
The biggest thing, or the biggest issue that I think we have in streaming in general is like consistency, and what should we say? The ability to guarantee that the data that you put through the streaming pipeline goes from edge to edge, and all the bits in between are doing the right thing. Because like classically in Kafka streams, you have this model where you can flow data through. It's not by default. It's not. What's the phrase? Like, we have to cut this bullshit down. Whereas, it's like read once. It's not like that. It's what's it called? At least once. Oh no, it's exactly once. It's exactly once processing. Yeah. God damn it, Walter. He's got me doing it. You have to cut that bit. So yeah, okay. The problem with Kafka streams is exactly once programming. Now they claim to fix this. They've got an option to do exactly once message transmission, but whenever I've used it, it's like the performances went to shit. Everything goes extremely slow, and also it seems to only operate between like one part of the overall system to another part, not the thing from end to end as you want to view it. So how does Rama compare to that in terms of like the guarantees that it offers for the data?
So Rama has two kinds of topologies you can create. They're basically two different ways of doing incremental processing. So one type of topology is called a stream topology, and that's the model of a stream topology is that you just process data as it arrives. So you're processing data one at a time, and it'll be processing many things or many depot entries in parallel, right? But each one is kind of the way each one is processed is independent from the others. At a high level, that's how you think of it.
It's like a map rather than
kind of, yeah.
Like a parallel mapping.
Yeah, the other one's microbatching. And microbatching, the idea behind microbatching is let's look at all the depots we're processing and all the partitions of the depots. We're going to see what data we haven't processed yet, and we're going to process that set of data as a batch, right? A so-called microbatch. And what microbatching does, basically with streaming, you can have either at least once processing guarantee or at most once processing guarantee.
Right.
And so if you're doing something like a count, then that means you could have errors, right? With at least with either of
Mm,
those,
mm.
either at least once or at most once.
Yeah, 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 yeah.
Microbatching, you can get a microbatching has an exactly once processing guarantee. It's actually really cool because it doesn't matter what your code is for your microbatch. The results, and it doesn't matter how many failures that you have, the results in the P states are going to be exactly once in every case. And you don't have to do anything special to get that. Basically, essentially, what a microbatch topology is, it's a cross-partition transaction in every case, no matter what your code is. You could be doing very complex things where you're writing stuff to multiple partitions. You could be doing looping computations, maybe like graph computations.
Mm,
Um,
mm.
all of it gets packaged together into essentially one atomic commit across every partition of every P state for the topology, which is very powerful. And also, microbatching, both streaming and microbatching. I want to be very clear. Streaming has very high performance, very high throughput,
Yeah,
but
yeah, yeah.
microbatching has even higher throughput because there's no per record overhead of processing. Because it's processing things as a batch, it's able to do things more efficiently. So basically, it's like even higher throughput, super high throughput instead of just high throughput. I'm not familiar enough with the details of Kafka streams to say why you would have been getting really bad performance, as you were seeing, but certainly Rama doesn't have those issues.
Yeah, I mean, maybe, I could be holding it wrong, but I've done it on several projects now with several people, and I've talked to other people on those projects that have been involved in it before, and they've all had the same experience. So, if we're all holding it wrong, then I feel like, okay, well, maybe it's a problem
Maybe
with
it's
the
designed
information
wrong.
or the design or whatever. Yeah.
There's no inherent performance cost to that. I can't comment on Kafka. I'm not familiar why it would have been selected. There's no reason it should be. You need to do microbatching to get the exactly once, right? So you cannot do push based one at a time processing. It has to be a coordinated everything at once and don't move on. But basically, the way it works is that Rama essentially is storing with the P states what. So basically, every microbatch has an ID, and it increases by one for every microbatch, right? So the first one is 0, the next one is 1, right? And the first thing a microbatch does is it goes to see, okay, what's the new stuff on the depot, right? And then it will store and replicate first what data are we going to read from the depot for this microbatch, right? So if we have to retry it, we try the exact same set of depot records, right? So maybe for this depot for partition 0, we're going to read records from offset 1000 to 1900, let's say, right? And if we fail, we're going to retry again. And the other thing you do is that the P states on disk are stored as commits, and every commit is for microbatch ID. And so if we need to retry the microbatch, the first thing we do is we revert those P states to whatever they were at the end of the last microbatch, right? And that's how it's exactly once, right? Because if you revert to the exact same state where you were before, and you process the exact same data, right? And you only move on if you completely succeeded. And the whole result of this, effectively, to like bring it into the database terminology, every microbatch, no matter what your computation is, and it's completely arbitrary logic that you're able to do, is a cross-partition transaction in every case, kind of on top of everything else. So it's very, very powerful computational tool. That was one of the big moments for me, was actually getting it to scale, because the first version of microbatching, it did not scale, and it was like very disconcerting because we released. I'm sure a lot of listeners are familiar with this, but a year and a half ago, we announced Rama by rebuilding Mastodon from scratch, and we made it scale to Twitter scale, right? And if you look at the chart, it's just a line, right? More nodes, higher tweets per second, and it's just linear. And Twitter was like in the middle, right? We tested like way above Twitter scale. The first time I ran that, it looked like y equals log of x. It was like not linear. It was bad, and now it had to do with the way that microbatching was detecting like completion of processing, right? So like processing for microbatch is distributed, right, and it's dynamic, right? So the original algorithm for that was similar to the Storm algorithm, which turns out does not scale for microbatching. It's fine for streaming, but was not scalable for microbatching. And so I had to come up with something new for microbatching. But then once I did that, and then it took a few iterations to get it like tuned correctly, and then it was like this nice linear chart, and that was, yeah, that was good to see.
Yeah. Yeah, I bet it was. Yeah. I think we had this discussion actually a bit in the offline chat. about that because I know I'd seen a talk that you mentioned about this the the what's it called, like the probabilistic algorithm that you're
Yeah.
using for determining the success of the transactions,
Yeah.
where you were essentially say, and I can't remember the details of it, but essentially it was you were saying that it was you couldn't prove that it wouldn't work.
No, it was no, you could prove it.
You can explain it better,
That,
okay?
that, that, that was the big innovation for Storm, right? I figured out how to make stream processing
Yeah.
guarantee data processing. And that's really the main reason Storm was successful, right? It
Yes.
was the first project to be able to do that. So you have arbitrarily dynamic distributed processing and it guaranteed the data to be processed. And essentially the way the algorithm worked is that like you have an event and the event does some processing and then it generates outgoing events which go to other nodes, right? Or maybe it's the same node, outgoing events.
Yes.
And the way
Yeah.
it would work
Yeah.
is it would assign
Yeah.
every node a random 64-bit ID, right? So a random long, right?
Oh,
And then
right.
it would um, essentially it was using XORing, right? So when events finish, they would send their it's called the ACK value back to the root of where processing started, and it would XOR. And every value that got generated ultimately would get XORed twice. Any value XORed with itself is 0. XORing is commutative. It doesn't matter which order they come back. And so once the root becomes 0, then
Right,
you know
right, right.
processing
Yeah.
is finished. But there is a small chance with every ACK, because they're randomly generated, that you accidentally become 0, right? But that probability is so low that you can
Oh,
ignore it,
okay.
right? It would like
Yeah, yeah, yeah,
it was
yeah.
something like at 10,000 acts per
Yeah, yeah, yeah.
second. It would take like a million years before you had one false act. And that would only be a problem if that happened to be one that failed, right? So
Yes. Yeah, yeah,
basically,
yeah, which was also vanishingly
yeah.
small.
So
Yeah.
the probability was super low. And so that's why it was a good album. And it was really cool because it was very little information that needed to be additional information that needed to be passed on with every message. And it was very, very little information that needed to be stored at the root, right? Just one 64-bit number. Super, super efficient.
Yeah.
So Rama uses the same algorithm or the same approach, but it improves upon it. It's basically like twice as efficient. And then for microbatching, it's still the same idea for microbatching, but the way the acts get propagated back to the root is different um, in order to make it scalable. So that's what Rama is doing.
Right, right. Nice, nice.
So you mentioned Hadoop right at the top of how you got into Clojure and how you wrote Cascalog and so on. Um, what is the there looks like a through line from watching the stuff you've done that it's a lot about big data processing. Like, how did you get into that world?
Well, that was just the first startup I joined was needed to do large scale processing. So that's how I got into it. And it was kind of the Wild West back then. It was like you had to do, but people didn't really know what they were doing. Like the vocabulary was still being established. So that was very interesting to me to figure it out. Um, and yeah, I thought a lot about it and then got into Clojure, started doing stuff with that. Probably got influenced by Clojure, like unconsciously, especially with immutability. Um, After that, I developed a lot of like ideas about like how to formalize this stuff. So that was like I wrote a book about it, like lambda architecture, which became like a pretty well known term, which is really based upon like immutability as a way to simplify the construction of software systems, especially large scale. And the thing about Rama, like Rama is can be used for large scale data processing, and some of our users are using it for that. But it's not just a big data tool, right? So basically, like where Rama helps like reduce the cost of software development is two things. One is scale, just because scale adds so much complexity to infrastructure. But the other one is complex domain models. The more complex your domain model, the more you're going to benefit from Rama, because you're not going to have to twist your complex domain model to fit your database, right? You're able to mold Rama to perfectly match um, your domain model, and that can it simplifies things a massive amount. And so that's why I'm not like in the marketing of Rama, I'm not like describing it just as a big data tool, right? It's a tool for building backends at any scale. The scalability stuff is like the more like eye-catching stuff, um, but it is really good for small scale stuff if you have a complex domain model.
But okay, so I mean, given that, I think this is really, I mean, this is like you said, super powerful. And what's been interesting to me is that, like, we've talked about the way of thinking and why productivity is important and efficiency and all these sort of things, and how we improve our thinking. But I remember when we first saw the marketing material for Rama was that you know, we were looking at like 100x performance, which is obviously a significant jump in terms of what you can do with any technology. So it's a big claim, and we're living in a world of big claims, like from like OpenAI and various other AI companies who claim that, at least on my version of GitHub, they're saying 38% more. My project can be 38% more efficient, whatever the fuck that means. But that's a sort of, that feels like what should we say, a lie, yeah. And I'm hoping that you can tell me why 100x, why Rama is not like in the same game as the AI people when it comes to like their claims about productivity. Where how can we get like more? How can we get more? How is it more convincing? How is Rama more convincing than some of these AI claims? Is that a fair question? I don't know.
Yeah. It is a fair question, and and it's weird because like, so first of all, that the 100x didn't come out of thin air. It was,
No.
I mean, that's why we announced Rama the way we did. Like,
Yeah.
we didn't just like announce like, oh, here's this event source and materialized views thing, and by the way, it's going to be 100x better than what you had before. That would be an insane thing to do, right?
Mm-hmm.
So we put a considerable effort to first of all, it's not like we started with 100x and then produced a bunch of material to support that. What we did, we did the work. But basically, the way we announced it, if anyone's unfamiliar, so we rebuilt Mastodon from scratch to be Twitter
Yeah.
scale. So Mastodon, it's basically the same as the Twitter consumer product circa like 2015,
Mm.
before they added the algorithmic timeline to it, right? So it was just like the regular following timeline, right? And you have a whole bunch of features there, who to follow and retweets and likes and favorites,
Mm.
muting and blocking and uh, all the different features you have for Twitter, right? So we built the whole thing from scratch. And then we looked at the amount of code we had to write to build it from scratch on the back end, and we compared it against two things. We compared it against Mastodon's implementation, like the official open source implementation, and we compared it against Twitter's implementation of just the consumer product, right?
Right.
And Twitter wrote over 1 million lines of code to build that product at scale. Mastodon's backend was about 18,000 lines of code, and our Rama-based implementation was 10,000 lines of code. And so if you divide 1 million by 10,000, you get 100x, right? It was 100x less code
Right.
to write. And then in our announcement blog post, I think it was like 14,000 words. It was a very, very deep dive into not just Rama, but into the Mastodon implementation and how it works.
Mm.
What are the distributed systems and scaling challenges that you have to face when building that product at scale? And then how do you actually solve them with Rama? And the way we solved those data processing and scaling challenges is the same things that Twitter did. And so like, just to like talk about a little bit about it, like to do that, like basically the challenge of that product is fan out, right? So delivering tweets to the timelines of your followers, right? Because essentially just amplifies the cost of every tweet. The average fan out on Twitter, I don't know what it is today, but 5 years ago or whatever, it was like 700. So that means one tweet, it's going to be on average 700 writes, right? So it's an absolutely huge write load. And it turns out that the way to do that product efficiently is you keep the timelines. First of all, you only keep like the last 5,000 entries on everyone's timeline or something like that. Or maybe it's only the last 1,000 entries. And you keep them in memory and you keep them unreplicated. And what that does is it actually makes them unreliable. So if that machine hosting that partition of timelines were to restart or go down, you lose all the timelines, right? But what you take advantage of is the fact that Twitter, the way data is indexed in Twitter is redundant because you can always reconstruct your timeline by looking at everything, all the tweets of everyone you follow, and you could reconstruct your timeline. And so the idea is that fan out, you make it much cheaper by keeping your timelines in memory and not replicating them. And in the rare cases that you have failures, then you just reconstruct the timelines on read. So when the read happens, you reconstruct it, and then you continue with normal. So Twitter did that by building a whole bunch of custom infrastructure by scratch. With Rama, we were able to do it by just composing Rama's much simpler primitives together in just a particular way for that application. So anyway, that blog post, it was a long blog post, and it went into detail on all of
It
that.
was a long blog post,
Yeah,
like
yeah, yeah.
Tolstoyan long, yes.
And that was my idea, right, with Rama. Like I'd been working on it already at that point for almost 10 years. It was this big platform full of new ideas, and it had these huge benefits. And so the idea of that announcement was to like overwhelm with substance, right? Just provide
Right.
a huge amount of evidence. Oh, by the way, we also, for about, I think it was 9 days, we ran a Twitter scale Mastodon instance live, and anyone could use it. And what we did is we had 100 million bots posting. We used AI to generate a bunch of tweets. And so they were posting 3,500 times per second. I think the average fan out we had on that social graph we generated was 400, I think. And it was a very unbalanced social graph, right? So it was very much a direct, like it was legitimately running at Twitter scale with a Twitter-like unbalanced social graph. And it was kind of funny just to watch, especially the global timeline. It was just like a massive stream of just the bots talking. I also had the bots, like they would like comment and retweet each other. It was kind of funny.
I don't want to know what happened on there. I mean, it's like vibe tweeting.
I mean,
and honestly, the quality of those bots talking was comparable to the quality of Twitter today.
I was about to make the same statement.
Anyway,
So
the point is that
yeah,
we didn't pull 100x out of our ass. Like we put in, like it took us 9 person months of effort to build Mastodon from scratch at Twitter, like end to end, and do the performance testing and and write that post. So it's very much a number. I mean, it's just literally 100x less code than Twitter wrote to do the equivalent, right? And the reason it took Twitter so much code to build that product was because they are using, it was built on traditional tooling, and traditional tooling wasn't able to do these things they needed to do with like the timelines, for example, being one example of that. So they had to build a whole bunch of custom infrastructure from scratch. And for every single time they do that, they have to solve the process management and replication and deployment and durability and monitoring. And they had to do all that from scratch every single time. And they had to do that for like, it wasn't just, they had to build multiple pieces of infrastructure from scratch. And that ends up adding up to a huge amount of code and many years of effort. And actually, I actually think like the 100x, like that's like the headline grabbing one, right? That's a big number. But I also think that the comparison of our Rama-based implementation to the official Mastodon implementation is also really interesting because the Mastodon implementation is not scalable and it's written in Ruby. Our Rama one was scalable and it's written in Java. Now, Ruby is a much more concise language than Java. And it is really unusual it is like unheard of for the scalable version of application to be less code than the non-scalable version.
Right. Yeah.
Like it's always a huge multiplier because of all the additional challenges you have to face. But what that demonstrates is just how good Rama's abstractions are and how much we have eliminated impedance mismatches. So our code is able to be to the point, and is able to be concise because instead of having to build stuff from scratch, we're just composing simpler primitives together.
Yeah. So out of curiosity there, Nathan, like if you combined the number of lines of, so first of all, like really quick aside, you wrote the Mastodon clone in Java, you said. Was that just to make it more comparable with the lines of code in like Twitter or regular Mastodon, or why Java and not Clojure there?
Oh, I think that's just because most programmers did not program Clojure, so we want to make it more
Okay,
relatable for
Accessible, yeah, yeah.
gotcha.
that.
Okay, so then the other question there was like if you count the number of lines of code in Rama itself and
Yeah.
add the lines of code of the Mastodon implementation there and compare that to Mastodon, then what do you get? Like, is it comparable?
Well, if you're going to do that, then
I know
if you
that's not fair, but
no, no,
I'm
no,
just curious
no,
here.
I'm saying if you want to do that, then if you want to do a comparison, then for the official Mastodon implementation, you have to add up all the number of lines of code for um,
All the libraries.
Postgres and Redis and all that stuff too, right?
Yeah, yeah,
Oh, good
definitely, yeah,
point.
yeah.
Actually, I didn't think of
Ro-
that.
ro- And that was one of like the really stupid things on the Hacker News comments for that blog post was people like their argument was like, no, it's not 100x because you're not counting the number of lines of code of Rama itself.
Okay.
But Rama's not a platform for like Rama's not specifically for building Twitter, right? It's a general
Right.
platform
Right.
that's
Yeah.
would be comparable in this case to your fundamental infrastructure like Postgres and Redis and all the other stuff is built on.
Yeah. Yeah.
Um,
Good point.
yeah, that's that was like that was like kind of infuriating just stupid how stupid those comments were. Um,
Sometimes people deliberately miss the point, though, don't they?
Yeah. So here's the thing. I don't read Hacker News, so I'm very proud of myself for independently recreating a stupid fucking argument. So
but yeah, and actually the number of lines of code. Actually, let me. What's the number of lines of code now? The number of lines of code now is more than it was when we first announced it. Obviously, yeah, the number of lines of code today for Rama, we have 224,000 lines of source and 301,000 lines of test. Yeah, it was actually a lot less code than like I think Postgres is like 6 million lines of code.
Wow. Yeah, yeah, yeah,
Yeah,
yeah.
but yeah, it's actually kind of surprising how little code Rama is when you consider just like the breadth and scope of what it can do.
cool. So Rama sounds amazing. I haven't had a chance to try it yet. My plan was between jobs that I was going to try it out, but then apparently I got busy with other stuff. I don't even remember what it was. So I'm still waiting to get laid off again. Fingers crossed that'll happen soon. So I have some time to play with Rama. But
We're all pulling for you.
yeah, thank you. I'm sure my boss doesn't listen to this. So unfortunately, I'll probably have to wait a little longer. Um, you said it took you 6 years to figure this out, and I know that it's Red Planet Labs, right? Is the name of your company?
Yes, not Red Plant Labs, which is sometimes I get emails saying that Red Planet Labs.
Planet.
Yeah.
So, if I remember, you all were kind of working on this heads down. I don't know if you would use the word stealth, but it certainly was like you weren't talking about it in the Clojure community at the time. Like, what was the motivation to do this, and how many people did you have at the start, and yeah, just tell us about the story of how this all came to be.
So I started working on Rama in 2013, which is 12 years ago now. It was March. I Twitter March. I think it was March 15th. Yeah, it was the Ides of March. It was March 15th, 2013. So that's almost it's March. Yeah, almost exactly 12 years.
Wow.
And so basically, Storm was a big project at that point. I could have started a Storm company very easily. I had a ton of interest in that. People were begging me to provide consulting services and all that stuff. But I ultimately didn't find that interesting to do that because it purely would have been
It was your Lisp, was it?
what was
It was your Lisp.
or Storm.
Like you were talking about McCarthy wasn't interested in Lisp. You also were
right,
just
yeah.
like, oh yeah, I'm not interested in it.
Yeah, I guess so.
It's
Sorry,
called
it
a
was a
callback.
callback. Forget it. Okay.
Yeah. But yeah, I was I was also working on my book at that time, right? Again, I said I'd been thinking about just like formalizing how to think about this stuff, Lambda architecture. which is entirely based around the concept of functions, right? That's why it's called lambda architecture.
Right.
I've been thinking beyond like Storm, just like building systems end to end. And I had already saw there the structure for a next generation platform for building software systems, right? Which ultimately became Rama. But at that point in 2013, I already understood that data storage should be in terms of data structures. That was just like brain dead obvious to me at that point. That's way vastly superior to databases. And I understood that like from Cascalog, that like data flow or like that style could be a really good way to express computations. I realized it would take me so many years to figure it out from that starting point, because it was grueling to figure it out. So, but I was determined to figure it out. And I was making progress. I was making progress, even if it was like not continuous progress, right? Even if I got stuck many times for like months at a time, like eventually I would figure it out and break through it. Essentially, like the way I approach programming, like any program, and this was essentially just this approach, like at the highest possible scale, is abstractions come from the unification of real use cases, right? I'm looking to build a next generation backend platform. I'm trying to unify every use case that has ever existed. And so that's what I was doing. I was thinking of everything I had ever worked on, everything I had ever helped to work on, which is a lot of stuff at Twitter and also through my open source work, especially with Storm, and trying to figure out how can all this stuff be expressed in a clean, beautiful, performant way in one simple set of abstractions that compose together. And that was hard. Like at first, you know, I understood that like it made sense that data flow would be a big part of that. I thought data flow would be more limited, more of like a DSL, but eventually I figured out it had to be as expressive as a general purpose programming language. That's probably the first few years. That's probably 2013 and 2015 until I finally accepted that, because God knows I resisted that for a long time. Probably around that time is also when I, rediscovered continuations, and that became a big part of the implementation. But anyway, it was grueling. And eventually 2019, I had it figured out, and I had a prototype, which was not distributed. It was all just running in process, but using distributed abstractions, just in a distributed way. And so then I raised money based on that. So I decided, okay, now it's time to raise money and accelerate this thing. So raise a whole bunch of money from some really good investors, and then I started hiring. So 2019 is when the company really started. Hired a bunch of people, and then it took until 2023 until we were ready to talk about it publicly, when we actually had a working system that could actually be used for production. And now we've reached the point where we feel it's ready for broader use.
So during the 6 years you were thinking about this stuff, were you also like, did you have a day job, or was this literally the only thing you were doing?
The only thing I was doing, yeah.
Holy shit.
Yeah.
So that's different from the experience of most programmers.
Yeah.
But when you developed Storm, that was you were working then, right? Like I
was working for a startup called Backtype. I developed Storm. Storm took like 8 months to develop, and then we got acquired by Twitter, and then I released Storm from Twitter.
Yeah. So how were you able to do that in very little time? Like, I mean, I guess it was part of your job that you were doing it.
So the scope of Storm is so much. It's like way less than what Rama does. Yeah. So Rama. So let's put it this way. So Rama. So let's say Storm took a year, right? Let's round it, and let's say Rama took 12 years, right? Except I'm a much better programmer than I was when I built Storm. So the scope of Rama is not just 12x Storm; it's more like a lot more than that. Yeah. Yeah.
So Rama was this white whale, basically, that you were sort of working on. But I think actually I got a question from a friend of mine who sort of knew you were coming on the show, and he was saying, well, it's like, isn't it strange that like you had that opportunity to actually kind of be a gentleman coder for 6 years, and is there something about like Silicon Valley or about the startup culture where you could essentially IPO out or something, or vest out, where you could be a bit, it's kind of like not what usually happens. Maybe it's more in Europe that we don't have as many people that have such I remember Rich when Rich was looking at closure, he was like, got his cap out and was,
Yeah.
busking for money and stuff like this. So, even when the ideas are really good, it sort of feels like you're putting a lot of your heart and soul into it. Because I guess at the end of the day, you're probably not, a super billionaire, so you're gonna run out of money eventually. So you were taking quite a gamble, I think.
Enough money from the backup acquisition that I had financial freedom to do it. So I didn't have to worry about that.
Right,
I mean,
right, yeah,
that's the reason I did it, because I was like, oh, I
yeah.
don't have
Well,
to, I actually have the opportunity.
yeah,
I have this amazing opportunity to actually pursue something really meaningful, right? I actually don't have to care about money at all at this point.
mm,
I mean, I would have made a lot more money then if I had,
mm,
even just staying at Twitter, I would have made a ton of money just because I had a lot more equity to invest. And I would have made a lot more money doing a storm company at the time. I think I'm ultimately make a lot more money from Red Planet Labs.
yeah,
But
yeah.
that wasn't really that wasn't my motivation.
No, no. No, but I mean, I get, and obviously, like you said, you might not have landed the white whale, and so it might not have, you might have given up halfway through or been frustrated. But so, kudos to you for sticking with it.
Yeah, I mean, I would have given up if I wasn't making progress, but I was making progress.
Yeah,
And I saw that it was probably about 3 years into it is when I was confident that I was going to succeed in building this thing. But
right.
in that first 3 years, it was I was making. First of all, I was making progress, and also it was a lot of fun because I was discovering fundamental new things in computer science. Uh,
Yeah, yeah,
so
yeah,
that's
yeah.
what kept me going.
So what does that actually look like? Your hammock time, like we throw this phrase around all the time, right? Hammock time, and it uh, in my mind at least, I always think of people like just kicking back and doing nothing but thinking.
Yeah.
But thinking can take many different shapes, whether that's like scrolling things on paper, banging stuff into a REPL. So like, what was your process like when you were figuring all this stuff out?
Well, it's a very good question you asked. I can see why you're hosting a podcast. I'll answer it as best I can, even though I'm just one man. And so basically what I would do is I would just sit there on my computer. I would have a text file open, and it's just free form stream of consciousness into that text file. I think that text file ended up being like 30,000 lines long or something. Actually, my original working name for Rama, before I came up with the idea, like the name Rama, I was calling it Supernova.
Mhm.
And so I have this file like supernova.txt, and it's like incredibly long stream of consciousness, just like kind of probably a lot of it's incoherent if I were to go back and try to look at it now. But it's just essentially just like writing, taking notes. It's a lot of just like spitballing, right? It's like, okay, here's this use case I want to do. Here's my ideas for abstractions. Let me try to work it out just in pseudocode. And then for those first 3 years, especially, for the most part, I would run into a roadblock where it was just like, it does not express via the combination of what I've come up with so far. And so then I have to take a step back, and then sometimes I'd get really stuck, and then I'd have to figure out which one of my assumptions is wrong, right? I mentioned that before with like the API for P states, how eventually I figured out, oh, it's Spectre. If it's just done in terms of as, it solves everything. And that was one of like the very memorable ones for me, just because it felt so stupid at the time that I had already created Spectre, was using it very heavily, but it took me so long to connect that to P states. But that happened so many times. And enough iteration, I eventually got there. I mean, everyone's different in terms of how they think, but
Yeah.
for me, it's just text files. I still do that. It's different. I've moved on to different files. Not super much text anymore. Now I'll create like a file per project, and I'll stream consciousness in there. Eventually, I figure it out, and then I'll write like a list of like steps. Like, okay, what's the steps I need to now go from this point to actually see it to completion?
On the stream of consciousness stuff, like I totally get how writing can help you think. Do you go back to the stream of consciousness? Like, do you read what you write?
Yeah, definitely. Yeah,
Okay.
I would go back. Yeah, we're talking very abstract now, right?
Yeah.
But yeah, just for like ideas, or maybe like there was one thing I was like, oh yeah, I remember I had one idea there, so I'll scroll up like 2,000 lines and eventually find it.
I,
Very organized. but that's just how that for me that's how I think the best.
Yeah, because the other, I mean, I think there's, I mean, I'm going to switch gears a little bit towards like the horrors of AI, um, and people are going to ask this question anyway, so we might as well just ask it. It's like, okay, if you were thinking like now, do you or would you have used an LLM to help with that process, or is that something which you still feel is a little bit, let's say, orthogonal to the way that you did your research?
I can't imagine an LLM would have helped with this, at least not LLMs as
Mm,
of now, because like I'm doing something completely novel that's never been done before, and is actually like against like the way things have been done, right?
mm, yeah,
So like LLMs are kind of the opposite of that, right? They're good at like patterns or showing you stuff that's pre-existing, right? And they can be really good at that.
sure.
I can't imagine it would have been good for or would have helped very much for designing Rama.
It's kind of funny for me because there's a lot of hype around AI as being innovative, but I completely agree with you that it's basically a kind of papier-mâché of what we've got now, rather than something which is going to provide a way to actually innovate on things.
Yeah, I mean, I think we don't know where AI is going to go, but I think the current state, I
Sure,
think is
sure.
like that. But I still find chatbots extremely useful. But you have to know you have to know where they're going to be useful.
Yeah, yeah. Because one of the things I was thinking about was that if Rama, like we were talking about this before as well, it's like if Rama is going to be a productivity tool and LLMs are a productivity tool, then how do we compare those things? Because clearly there's very little, a very small body of like knowledge about Rama in any LLM, and maybe that will grow eventually, but still,
Yeah, we're going to be investing more into this, but I think first of all, they're not. I actually think they're incredibly synergistic. I think coding tools that are targeting Rama are going to be way better than coding tools targeting traditional systems because Rama simplifies development so much, and so it's going to enable AI to be doing much with much less code, doing things in much bigger scope. So we're gonna be pursuing that to see how far we can get with is this technology. We haven't started that yet. I don't know how much exactly how we're gonna have to approach it. Like, do we have to fine tune a model for it? But I do think that like theoretically, it does seem like coding tools will be really really good on top of Rama.
So Rama, where did the name come from then? You hinted that or no, you didn't hint. You just fucking said it. Sorry, am I allowed to swear on here? Where
No,
did the name Rama
we'll
come
get the editor to that.
Excellent.
Do you guys read a lot of science fiction?
Yeah.
Yeah.
No.
Well, it comes from a very famous science fiction book, Rendezvous with Rama by Arthur C. Clarke.
Okay.
Yeah, one of my, I think it's probably my favorite science fiction book of all time. Yeah, so that's where it comes from. If you've read the book, you'll understand why it's named Rama.
Okay.
I will now read the book. I have read some Arthur C. Clarke, but clearly not
Yeah,
that one.
one of the greats. Yeah. What's his? He had that famous quote. What was that quote? There's sufficiently advanced technology is indistinguishable from magic.
Yeah. Yeah.
Yeah.
We've hit that on this show before, a few episodes back with Catherine. Yeah.
So that's what Rama is then.
Sufficiently advanced
Yeah.
technology.
Well, there's a more specific reason why it's called. If you read the book, there's a more specific reason why it's called
Okay.
Rama.
Okay.
So actually, the name Rama is funny because I just named it after the book. I didn't know anything else about the word Rama. I didn't know that Arthur C. Clarke got the name Rama from Indian mythology.
Yeah. Yeah.
Yeah, and there's like a huge thing in Hinduism and all that stuff. So when I found that out, I was like, oh shit, I might have like really screwed myself because I don't know if this is some like evil thing, but it turns
All right. Okay. Demon. Yeah.
Rama, that character is like fine. There's nothing wrong. I was
Okay.
kind of scared when I first learned that. I was like, oh, because I was so happy with the name because it's just like it's 4 letters,
Yeah.
easy to say, it's easy to pronounce. It's like the ideal name and it's unique.
Hmm.
like exactly what you want from a name, and it has just this really cool like meaning behind it from that book, right? In terms of where it comes from. So I was really glad that I was able to stick with that name.
Nice. Nice.
Naming is
Glad it
hard.
worked out
Yeah.
for you.
Yeah, like I like the name Storm too, but Storm turned out not to be a great name because it's too common of a word.
Right.
And it actually ended up being like this legal thing. There was some patent troll which got like a bunch of trouble for like I donated Storm to Apache. It caused a bunch of trouble with Apache because the name Storm was too common. So yeah.
So
All
I
right.
guess we have been talking for a while. Yeah, is there anything you kind of want to leave us with before we hit the exit door?
I actually have a question for you guys.
Go for it.
Because you guys have done what, like 100 episodes of this?
Something
Well,
like
not
that. Yeah.
me, but Ray. Yeah.
But okay, so you guys, so I feel that your listeners, they've been listening to you guys ask questions for so long. They would want to know some things about you guys. You guys are kind of this mystery to your listeners.
We want to keep it parasocial. Come on.
I'm just curious, why did you guys start doing the podcast, and has that motivation changed now that you've been doing it for so long?
Well, we had a recent personnel change with Josh, because myself and VJ started it, and we met at a closure conference in Amsterdam that he was organizing, as it turns out. And I don't know, I just suggested to him that we had a nice conversation, and there wasn't really, apart from the Cognicast thing, there wasn't really a closure podcast at that time. And also, I thought me and him were both kind of like jokey and a bit irreverent, I would say, if not downright rude. And that vibe is something that we've continued. And obviously, Josh is irreverent as fuck as well, so that's good. And we wanted to make something which was more, yeah, a bit more, a bit more casual and a bit more irreverent than a lot of programming podcasts and certainly a lot of closure. I think like the Cognicast was super nice, and I think it was like, to my taste, it was a bit over nice. And it wasn't as like, it didn't actually interrogate anybody or have a proper discussion about stuff. And so yeah, so it turns out that that was enough of a motivation for us to start talking about it. But funnily enough, we didn't actually think that I didn't. The motivation was really just for me and VJ to shoot the shit for as long as we wouldn't get bored. But we started talking about the REPL on the first episode, I think, and Mike Fikes, who you might know from the ClojureScript community, is like a total god, and he's just such a nice guy. I've ended up working with Mike as well in another job. And he's such a lovely guy. And he got in touch with me and said, "Oh, if you're interested in talking about the REPL, I know a lot about this stuff, and I could make moves, jump in and help you out." So he became the first guest, and then we figured we might as well invite some other people because they're far more interesting than the kind of first 2 or 3 episodes that we put out. They were total garbage, So yeah,
Cool. So it's just fun, and it just continues to be.
it's just fun. I mean, and to be totally honest, we try to keep it relatively low effort as well, which is kind of what makes it sustainable. And then a friend of mine, I was doing the editing, but a friend of mine was giving me advice, and eventually I just said to him, "Look, Wouter, maybe it's better if you just do it, because you're giving me so much advice, and I know you know how to do this shit." So he, out of the kindness of his heart, he agreed to do it, and that was nice. And honestly, it was just to be honest, it's like, it's a new medium. I've never done anything like this before myself. Neither had VJ, neither had Wouter, and so it was just something fun. And also, I mean, let's be honest, I get to speak to people like you. It's just incredible to me. I'd meet occasionally people at conferences and stuff, but never really get the chance to have in-depth conversations, because you're always kind of like interrupted. It's always 5 minutes here and 5 minutes there, and it's kind of unsatisfying. So yeah, it's kind of like greedy, really, I guess, to be and lucky that we get to invite, and that you actually amazingly come on and talk to us.
Yeah, it's interesting how podcasts just the way podcasts have exploded, and they've kind of
Mm.
replaced talk shows like on television at this point.
Yeah, definitely.
There weren't a lot of programmers going on talk shows.
The other thing I really like about podcasts, I mean, which is kind of like, it's kind of like the old web in one sense, in the sense that it hasn't really been dominated by any particular company. So like Spotify doesn't own podcasting, like Google owns search.
Right.
Yeah, as
You know.
much as they would like to. Yeah.
Yeah, they want to do it, but there's all kinds of, iHeart Radio, and there's a whole there's a podcast meta industry building up and building
Right.
up, which I'm kind of like fearful of, to be honest. But the fact is that you can just make these shows, put on our RSS feed, and bam, you're out in the world. And we're kind of amazed that anyone listened to us, but then like after I don't know, 6 months or a year or something, I think because obviously the guests were so interesting, we did get quite a following. I actually don't know what the numbers are, to be honest. I never look at that kind of stuff, but it's certainly like, or at least it was at one point like a few thousand, which is completely amazing to me.
That's like 100% of the Clojure programmers in the world.
Yeah, exactly.
You better hope not.
There's probably more than that. Actually, I do wonder. Actually, are there numbers on that? How many, or any estimates on how many Clojure programmers there are? There's like, how many are in the Slack? There's 30,000 in the Slack.
Oh, wow.
There's a shitload more than that, obviously, as well. Yeah.
Right. Although, actually, that did just make me think of, there's a great clip, if you look on YouTube. Grace Hopper was on the David Letterman show in the 1980s.
Really?
And she killed. He was amazing. So just like one of the few instances of a programmer, making it to the big time like that. So it's every programmer will greatly enjoy watching her then.
Right, we've got to look it up, put it on there.
Yeah, definitely gonna dig that one up.
Yeah, but funnily enough, I think VJ gave up after 100 because he'd like made his goal or whatever.
100,
yeah, it's nearly 100,
yeah.
And but I spoke to Josh about it, and it was like, yeah, it's something that he was interested in. We wanted to give it a refresh as well and keep it going, but keep the same spirit. So yeah, maybe you can speak to it, Josh. What's your kind of motivation?
Oh, for being on the show? Well, I mean, we were talking, and you mentioned VJ was going to retire. Hang up his Emacs claw. And I think I said, if you ever do guest hosts, I could come on for one and, shoot the shit with you and somebody. And somehow come on for one turned into, come on for all of the ones. But yeah, I mean, it's very similar to what Ray said. Like, it's really interesting to talk to people that otherwise, you would, you might chat on Slack with, but or see at a conference, but to get to talk to people for like an hour plus and hear hear stuff, it's interesting. So
have you guys ever tried to get Rich Hickey to come on?
Yeah, we have. Yeah, we've had Alex on, and he was really good, but I think Rich is not interested.
Right.
But, we'll see. We can keep on asking. Maybe he's got more time now.
Yeah.
Right.
I think also we're a bit like you said at the beginning. We're a bit like we don't have to give a fuck because nobody is paying for us to sponsor this stuff. So I mean, obviously we don't ask really very hard questions. We're not that clever. So but yeah, it's fun.
I thought they were pretty tough questions.
Well, you coped very well. Okay.
Nice.
With the onslaught.
I hid my fear.
No, thanks very much, Nathan. It was really appreciative. I'm really appreciative of your time, and yeah, it's been great to meet you, and thanks for your questions as well.
Yeah. I'll be I'm gonna be in London in May for the Reclosure conference. So if you guys want
oh wow, okay, great.
We got to go to that.
Yeah. James mentioned it at the Heart of Closure, so yeah, that's gonna be great. Okay, fantastic.
Yeah.
Let's hook up.
Cool.
Yeah,
and maybe I'll get laid off before then, so I'll have some time to play with Rama. So,
That's the ideal,
yeah. Well, I think the motivation that you've given us is really strong for it. So great job on that. And yeah, definitely look forward to seeing the free version and the blog post coming out. So yeah. Fantastic.
All right.
Yeah,
Nice
thanks
one.
very much.
Thanks for coming on.
Thank you for listening to this episode of DefN. And the awesome vegetarian music or the track is Melon Hamburger by Pizzeri. And the show's audio is mixed by Wouter Dullert. I'm pretty sure I butchered his name. Maybe you should insert your own name here, Dullert.
Walter Wouter.
If you'd like to support us, please do check out our Patreon page. And you can show your appreciation to all the hard work or the lack of hard work that we're doing. And you can also catch up with either Ray, with me for some unexplainable reason. You want to interact with us, then do check us out on Slack, Clojurian Slack or Clojureverse, or on Zulip, or just at us at Defen Podcast on Twitter. Enjoy your day and see you in the next episode.
I don't know, Ray. But anyway, ending this tangent.
Right.
Because
Okay.
this
Yeah.
slammed into the brick wall of your ignorance and imperialist mindset.
Maybe we'll cut this bit because it's absolute bullshit, and
definitely.
you know,
This is,
we're definitely not destroying Nathan at this point. So let's get back onto that. You know.
Yeah, he's turned the tables. Like he's making you sound like a right Egypt. I mean, this is great. Walter leaves. Walter.
God damn it, Nathan.